Today, your objective is to graph and evaluate piecewise functions. To start, we'll do an introduction question. A cell phone company offers the following plan. $20 per month by 60 minutes. An additional time costs 40 cents per minute. We can represent this plan by writing the total monthly cost as a function of the number of calling minutes t. Okay, so we can write the function c of t equals, we have 20 if t is between 0 and 60.
How come you color that?
So what we're thinking here, that the cost is $20 for 60 or fewer calling minutes. The additional time costs 40 cents per minute. So what we would say there, we would say 20 plus 0.40 parentheses t minus 60 if t is greater than 60. So what this means is the cost is $20 plus 40 cents per minute for each additional minute over 60. This leads us to our piecewise defined definition. A piecewise function is defined by two or more equations over a specified domain. The domain are these inequalities we just looked at. Now we're going to use that function that describes a cell phone plan to find and interpret each of the following. So the first is c of 30. So to find c of 30, the first thing we're thinking in our minds is that c equals 30. Right? Since 30 is between 0 and 60, we use the first line of our piecewise function. This means that c of 30 equals 20. So what this means is regardless of the function's input, the constant output is 20 because there is no t variable. And again, with 30 calling minutes, the cost is 20. Moving on to b, c of 100. Remember, if I'm finding c of 100, then that means t equals 100. And because 100 is bigger than 60, I'm going to replace the t in the second equation of our piecewise function with the 100. So that means when I replace the t with 100, we actually get a cost of $36. This means that with only 100 calling minutes, the monthly cost is $36. When I evaluate a function in a piecewise function, the first thing I have to decide is where my x value, which piece it falls into. So if I have f of -2, -2 is smaller than 0, so I'm going to plug it into 3x plus 5. Okay, so f of -2 equals 3 times -2 plus 5, which gives us -6 plus 5, which is -1. If we look at b, we want to find f of 0. Well, 0 is greater than or equal to 0, so we're going to use the second equation to evaluate the function. So f of 0 equals 4 times 0 plus 7, which just gives us 7. If we look at letter C, it says we want to find f of 3. 3 is larger than 0, so we are going to use the bottom equation again. F of 3 equals 4 times 3 plus 7, which is 12 plus 7, which is 19. So now take a minute or two and try the next two problems. These are the two answers you should have found. For A, f of 0 should be -3. The reason being, to plug 0 in for x, you have to use the top equation. So what I wrote here is actually incorrect. The top equation, 0 is bigger than -3, right? So f of 0 actually is 0 plus 3, which is +3. In B, f of -6 should be +3 because +3 is smaller than -6 is smaller than -3. So we have -6 plus 3, which is -3. And we've done this one, so we can skip it. Next, we will be graphing piecewise defined functions. I would break this into steps. So first, I would take this first equation, or this first piece of the piecewise function, and note that it graphs a line, and I want it when x is less than or equal to 1. If it were me, I would make an xy table with my boundary point. X is 1. I plug 1 in for x, so 1 plus 2 is 3. So I'm going to plot the point 1, 3. So then notice our slope is +1. And if I want x values less than or equal to 1, I need to have smaller x values. So I'm going to go down 1 and left, because that still gives me a positive slope. And then I'm going to do it a couple more times. And then I'm going to connect the dots. Okay, now note that it says less than or equal to if I erase this big red circle. And so that tells me that this dot here needs to be a solid dot. If I go to equation 2, it just has 4 if x is greater than 1. Okay, so if x is greater than 1 and we just have 4, we're going to do an xy table. And in this case, it doesn't matter what we put in for x because the y value is just going to be 4. And because it is a greater than sign, we will use an open dot. Greater than 1 means we want to go in a positive direction for x, and because y equals 4 is a horizontal line, we just draw our line. And there's our graph. Take a minute or two and try this next problem. This is the answer we should have gotten on this piecewise defined function. Notice that in the first piece, we have a horizontal line again when y is equal to 3. When x is less than or equal to -1, we use a solid dot at -1, 3. And we graph all x values smaller than -1. For the second equation, we want when x values are greater than -1, so we use -1 in our xy table. We do get y to be -3. Because it is a greater than sign, we use an open dot at -1, -3, and we want greater than x values greater than -1. Dun 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 dun! Here's your assignment. The end.